All right, so here we go with normal distributions, and this would be example 10b. So it asks us what score. We already set this up in 10a. We're talking about the SAT. It's normally distributed with a mean of 998. What score would represent the third quartile? So I hope you recall from before spring break, we called that quartile 3, Q3. Most people understand that best as percentile. And as you recall, 3/4 of the data would be 75%. So I hope your logic would tell you that if you score at the 75th percentile, you would be above the mean. And so that score we're looking for is up here above the mean. And again, one more time, how do percentiles work? If you score at a certain percentile, 75th percentile, 75% of all the other scores fall below your score. So all this area here needs to be 75%, all that area below that test score. So all this right here is 75% for here to forever to the left. And so if we draw the corresponding standard normal, bell curve 0 in the middle, z-score, shaded area 75% to the left, forever. All right? That's a good start. So then we're thinking about the table here, and we're pretty close to the table, but hopefully you go, table, I got a picture of you, 75%. You're not going to find 75% in that table. How come? This table doesn't deal with those kinds of areas forever to the left. There are other tables that do. This table says, table, want, middle, sliver. Table, want, middle, sliver. Once again, the area, the sliver from here to the middle is what's going to be in that table, right? This little area right here. And so I hope your logic would help you realize that we can subtract from that 75% the entire lower half of the bell curve. And so if we take that 75% and subtract the lower half of the bell curve, that would leave 25% for that middle sliver that the table wants. 25%, that's what this area is that the table wants, 25%, 0.2500 right there in that middle sliver. So 25% in the body of the table, and I see that 0.2486, think of that as being 2,500, so 2486 and 2517 are the two that surround it. And if you subtract, this is 14 away, this one is 17 away, 14 is closer. The 2486 would be the one that wins. And if you look at this, that lines up with the z-score of 0.67. 0.67. Always be careful when you're talking about z-scores. What side are they on? This one's on the positive side. That's important. If you put negative, you'll be on the wrong side. It's all messed up. One number, and it changes everything. All right, so then, once again, the way that we would translate that back to an actual test score would be through this friend of ours that interprets things. So, 0.67 equals x minus 998 over 202. Ready? 1, 2, 3. It's just algebra. Solve for x. All right. So we'll multiply both sides by 2 over 2. 1, 2, 3. Over 1. Cancels. All right. And then on this side, we'll multiply the 202 as well. All right. And again, this is just arithmetic, right? 202. Now it'll serve me right if I do something wrong, after being so snobbish about it. So you can laugh at me forever and ever if I mess up on my arithmetic. Of course, you're probably laughing at me forever and ever anyway, no matter what I do. And I don't blame you. But anyway, and then add over the 998. And this would be the test score, 1133.34. And I would just come up here and say, all right, that's quartile 3, which is in turn percentile 75, 1133.34 would be the answer for this. All that work for that one number. Isn't that exciting? So, there would be example 10, part B. I hope it made sense. We have one part left, 10C. And we'll go from there. See you later. Numerator. After a while, percentile.